Hello everyone, welcome to this class, and in this opportunity we're going to be talking about genetic types in Java. So a genetic type, before we explain what a genetic type is, let's think about some of the cases in which we've been using genetics before without noticing. So we've done it before using array lists and hash maps. Let's see if we can remember that. Every time you create a new array list, you need to define what sort of elements you're going to hold in that array list. And the same thing happens with the hash maps. You need to define what is going to be the type of your key and what is going to be the type of your values. So let's have a look at that real quick in Java. So if I want to create a new array list, I need to define in my diamond brackets that this array list would be an array list of strings. So my AL equals to a new array list. And then in here we define again which one is the type. And now my array list is ready to go. But this is only possible because the array list is a generic. I can create an array list for Boolean. I can create an array list for whatever object we want. For example, in this case, I have another class there called box. So I can define an array list for box there if I want. So I can define an array list for any type of object that I want to use. So that is exactly what a genetic is. And that's exactly what I want you to do today. That's what we're going to be taking a look. How can I write a class that can run from for any type of objects without having to declare one of them in particular? Now, I can have two things. I can have generic classes and generic methods, but I'm going to focus on generic classes. Now, inside the generic classes, we're going to define some generic methods as well, but all in all, the focus is going to be on generic classes. So on the screen, on the slide, we have an example of a generic box. And I put that in your sample code, the pre-class code that you have up on Moodle. So in this box, I have an element and I haven't defined what is the type of the box. I've just said that this box will work with a generic type T. Now, does it have to be a T? No, it could be any letter, but by convention, it's normally a capital letter. So it could be T, E, S, whatever letter you want in there, but normally it is defined as a capital letter. So I'm just saying that the attribute element is of the type T. And that type T could be anything that gets assigned when the class is instantiated. Then I have a constructor. The constructor box takes the element T of whatever type has been defined. And finally, I can assign that to the attribute of the class. And I can define also my generic methods. A get element which will return the element of the type T, regardless of what type that is. And the set element that is going to take an parameter of the type T, whatever T is. So let's take a look at this. So that is the sample code. That is exactly the sample code that I have put up on Moodle already. So take a look at that and make sure you understand that. So what I really want to do now is I want to use it. So in my client class, in this case, in my main class, I can create an instance of the box, but because box is generic, I need to define what is the type of this box, or what is going to be the type of the element that the box is going to contain. So for example, I can define it as string, and I can say my box is equals to a new box, again, string, because in the constructor, we have defined that we need to pass in the object. So I'm going to pass in a string, Amilcar. So as you can see, I have defined that this object box is going to hold a string internally. So if I pass something else, it's going to complain. So for example, if I pass an integer, it is going to tell me, yeah, no, you have defined the constructor string for string. So it's one of the options is changing the constructor. Instead of taking the object t, you can change it to take the object integer. So I'm just going to go back to a string. Now, does that mean that I cannot create a box with an integer? No, I actually can create a box with whatever object I want. So I can say, for example, box integer, my int box is going to be equals to a new box. And in this case, we're going to say integer. And now I can pass in a number 10. And I can do this with any type. Suppose I had a type person, for example, which we could have. I can create, actually, let's do that real quick. I'm going to create a class person, for example. So it doesn't matter what I have here. It could be empty or not. It doesn't really, it's not really relevant. But now that I have that class person, I could create, if I wanted, a box for person. So I can say box person, my person box is equals to a new box for person. Of course, because we have defined the constructor that it needs to receive the element itself, I need to pass in here a new instance of the person class. Okay. Now, when would we use something like a generic class? Well, normally when we talk about collections, anything that can hold other data, anything that can hold other type of objects. So if you want to define something that can hold any type, then definitely a generic would be your option. So there are other modules in CCT where you're going to be writing your own array list, when you're going to be writing your own data structures. And if you want those data structures to use to hold any data internally, then the way to go would be define them as a generic. As I said, all the collection framework that we did a couple of weeks ago has been written using generics. The whole point is that whatever data that you put in there can be defined through the generic class. Brilliant. Well, that's it about the generics. I hope you like this video, and I'll see you in the next one.